All right. Hi, Block 7. I'm sorry I'm not able to be here with you, but I'm here live with Block 4. Block 4, you want to give a shout out to Block 7? Hey! Block 4, always a good time. Okay, so at this point, we were wrapping up section 1.8, and in 1.8 we were talking about f of x and g of x and how to find the composite of the two functions, and where we kind of left off last class was on finding the domains of these functions. So let's revisit that and finish up section 1.8. So if we're finding f of g of x here, we would say we want f of the g of x function, which is x squared plus 4, and then we would have the square root of, we're going to plug in x squared plus 4 into these f functions. So x squared plus 4 is going to be going in right here. So we would have square root of x squared plus 4. Everybody agree? Yes. All right, and let's back up for a second and talk about the domains. The domain for this function here for f is what? What's the domain?
Greater than or equal to 0.
All right, so x has to be greater than or equal to 0, or you could use interval notation. And what about the domain here?
All real numbers.
All right, so all real numbers. All right, and so if we want to find the domain of f of g of x, my rule that I would suggest, and I was kind of tripping on this yesterday in block 7, my apologies, block 7, but my suggestion to you is this, that you always say, if you're looking at the looking for the domain of f of g of x, you have to have the domain of g of x first and foremost. That's got to be the consideration, because if you can't plug it into g of x, then you cannot plug it into f of g of x. Does that make sense?
Yes.
All right. And if anything else pops up, like a problem with the overall function, then that has to be addressed also when you list your domain for f of g of x. So in this case, we know that it was okay, all real numbers were okay for g of x, but now when we look at f of g of x, it's this function, right? So is there any way to get a negative number under the radical? No. So the domain here is still going to be all real numbers. Everybody agree?
Yes.
All right, what about g of f of x? We said that was going to be g of square root of x. And if we go to the g function and we plug in square root of x wherever we see an x, we would get square root of x squared plus 4, which I was saying last time was absolute value of x. Let's set that aside. Don't worry about that. It's just going to be x plus 4. However, the domain we need to talk about, remember, the domain for g of f of x is going to be the same as the domain for f of x, and possibly with some additional restrictions. All right, so what's the domain for f of x?
X is greater than or equal to 0.
X is greater than or equal to 0. So in other words, here's our function. X plus 4 is g of f of x. But the domain is going to have to still be x greater than or equal to 0. Again, the reason, if we cannot plug it into f of x, then we cannot plug it into g of f of x. All right, are we okay with that?
Yes.
Does that mean if you can't plug it into g of x, like for the first one, if you can't plug it into g of x, then there has to be a restriction on x?
Right, so if you're talking about f of g of x, if there was a restriction on g of x, that same restriction would hold for f of g of x. Steph? I would say, I thought it would, and then I'm looking at your textbook with some of the answers, and they did not do that. So I would not worry about absolute value in this case. All right, so moving on. Okay, so maybe you noticed in some of your homework problems like this, where you were given a composite function, they're calling it h of x, and you're supposed to find two functions, f and g, such that if you take the composite of f of g, you will get this new function h of x. Were some of the homework problems like that?
Yes.
All right, so let's revisit and so we'll talk about what could be the inner function and what could be the outer function. So you are coming up with your own f of x and your own g of x, so that if you take the composite of f of g, you will get this function here. So what could be the inner function in this example, Alexis? Cubed root of x over 5. And then you want f of x to be 8 minus x. So if we took these functions and we did f of g of x, we would be saying we want f of cubed root of x over 5, and we want to take that and go to the f function and plug it in for x. So we would get 8 minus, you want to switch them around? Oh, that's okay. That's right. Sometimes you got to play around with them to see what's going to work. So what we said, well, let's back up. So do we see why we're abandoning this? Because this is going to get us 8 minus cubed root of x over 5, which is not what we want, right? We are looking for this. All right, so instead, though, if we switch these, so it won't look like this anymore. It will look like f of 8 minus x, and we plug in 8 minus x into the f function right here, and we get cubed root of 8 minus x over 5, which is what we wanted to get.
How do you find them? Do you just like take functions and plug them in and see if they work?
Take functions, plug them in, see if they work.
Okay.
Sure, you can use guess and check. Is this the only combination? No, there are multiple answers possible for this type of question. Are we okay with this? All right. And then let's take a look at one last example from section 1.8. And this is actual example 7 from page 88 in your textbook. So let's take a look at that. This is example 7 on page 88. If you have your book open to page 88, that would be great. Just give me a current change for you, because I dump all my stuff on that. Oh, gotcha. Well, then I can make you a little bit more comfortable. Be welcome, my friend. Oh, honey.
I want to be welcome.
Remember, I teach blocks 2, 3, and 4, and the stuff piles up. So I still stuff out like from block 2. All right. Okay, so we're looking at example 7. It says number n of bacteria in a refrigerated food is given by that degree 2 quadratic function, and it says capital T goes from 2 to 14, where capital T is the temperature of the food in degrees Celsius. When the food is removed from refrigeration, the temperature of the food is given by capital T of T, which is here, and that is 4t plus 2, where t is between 0 and 3, where lowercase t is the time in hours. So you are supposed to find the composition n of capital T of t and interpret its meaning in context, and then find the time when the bacterial count reaches 2,000. So yes, we are discussing how bacteria grows in food if it's left out of refrigeration. Okay, yum. All right, okay, so going back to this, if capital T is the temperature of the food in degrees Celsius, what depends on what? Does the temperature depend on the number of bacteria, or does the number of bacteria depend on the temperature?
Number of bacteria depends on temperature.
All right, so the number of bacteria depends on the temperature, and we're using capital T for that. All right, here we have our equation for temperature with related to time, where we're using lowercase t for the time. So what depends on what? Does the temperature depend on the time it's been out of the refrigeration, or does the time it's been out depend on the temperature? All right, the temperature depends on the time. Temperature depends on the time out of the fridge.
Wait, can you like re-explain why that's that?
Why what? This,
I understand the first one, but not the second.
if you take something out of refrigeration, the amount of time it's been out will determine the temperature that it's at, right? If it's been out longer, it'll be at a temperature closer to room temperature.
The temperature of the substance.
The temperature of the food that you've taken out of the fridge. So if you take out, oh, you know what, I'm going to take out this leftover chicken from yesterday, I'm going to set it on the counter, and phone call, oh yeah, I wanted to watch this TV, and you forgot about the chicken, right? Meanwhile, that temperature of the chicken is becoming closer and closer to room temperature. Agree? Does that make sense? So the temperature depends on the time that's been out.
Okay.
Okay? All right. So, what is n of t of t? N of capital T of t, that's going to be n of, what was our equation? 4t plus 2. And that means we need to plug in 4t plus 2 wherever we see a t in the n of t equation. Right? So, are you focused? All right, and so we would plug in 4t plus 2 here and here. Everybody with me? So we would get 20 times 4t, no, not a capital T. 20 times 4t plus 2 quantity squared minus 80 times 4t plus 2 plus 500. Everybody get the idea?
Yeah.
All right. They show you in the book on page 88 how to simplify that, and they get it down to 320 t squared plus 420. All right. That is your composite function, n of capital T of lowercase t. The 4 lowercase t plus 2 was our inner function. So that's got to go in for the capital T in the outer function.
So like,
It's like f of g of x.
Yeah, so like in the parenthesis, like the one that's closer into the parenthesis, I guess. I don't know how to word it.
And the inner, this would be your inner function,
Yeah.
and that, whatever that is, gets plugged into the outer function, right?
So it's like whatever ends.
Well, whatever the variable was in that, in this case it's capital T. So we take out all the capital T's and we plug in 4t plus 2. Okay, so what does it represent?
I just have a question first. So let's say for n t of t, and it was like a trinomial that's able to be factored, would you like us to factor it and simplify it all the way, or leave it as like a trinomial?
I would not worry about that. I mean, in the case, especially with this example, this is like a real world problem. We're just trying to get some understanding of this real world problem. I wouldn't worry about simplifying and so forth. Okay, so the question was, interpret the meaning of capital N of t of t. So what does this mean? What do we get if I plug in a lowercase t here, like 2, for example? What am I getting out? So 320 times 2 squared plus 4, what is that giving me?
the number of bacteria, amount of time.
All right, so our answer is the composite function gives us the number of bacteria that we will have in the food depending on the time that it's been out of refrigeration. Everybody understand that? Okay, and then you can see part B. If you plug in 2,000, oh no, it says find the time when the bacterial count reaches 2,000. So you would have to I gave a different example there. I didn't want that. Oh yeah, so you would just need to set this equation equal to 2,000 solved that for you on page 88, and it looks like it's about 2.2 hours. T turns out to be approximately 2.2 hours. So only 2.2 hours, that chicken that you left out will have a bacteria count of about 2,000. All right? Yeah, so, moral of the story, keep hot foods hot, keep cold foods cold. Okay,
What if you like shit it?
my work here is done. All
What
right.
if you thaw it? That
You don't thaw chicken out on the counter. You mean like frozen chicken?
Wait, where do you thaw?
Frozen chicken should be thawing in the refrigerator, and then when you're ready to cook it, you take it out of the refrigerator.
When you put like steak, we put it in the steak and
Okay, all right, that's all I wanted to say about this. Now, here's what I want to do. I want to give Cindy, who had a special problem, and Nikki, who had a special problem, I'm going to give them a chance to demonstrate those on Monday, which is our next Blue Day. Nikki's doing her celebratory dance right now. Cindy's doing a clapping
I think
thing.
it's gonna turn into Ice Age.
I just don't know what it is.
Okay, so at this point,
I just
all right, so at this point, we're going to take a look at some things from section 1.9. Would you take out your notes, please? We're looking at section 1.9. Can I have the talking stop, please? That goes for you too, Block 7.
Oh, we're still recording.
Alex, focus. That has been recorded. Okay. All right, so we're looking at section 1.9, which is on inverse functions, the learning objectives. You do not need to write these down, just look and listen. You need to be able to find inverse functions informally and verify that two functions are inverses of each other. You need to use graphs of functions to determine whether functions have an inverse. And you need to be able to use the horizontal line test to determine if functions are one-to-one. Maria, are you focusing? And you need to be able to find inverse functions algebraically. All right, so let's take a look at this example. All right, if you have a little function where you input the hours that you work and the output is the money that you earn. So who has a job here that is willing to share? Cole, tell me about where you work.
I work at my parents' restaurant.
And you get a set amount per hour?
It's about,
Or is it just under the table, here son, have a
it's
20?
under the table, but it's approximately about $10 an hour.
What?
That's so.
Okay, that's all right. We'll go with Cole's example.
I'm telling you.
All right, so,
This is why I should be president.
okay. Excuse me.
Real.
So, if Cole is making $10 an hour under the table, so the function would be what? F of x would equal what? 10x, where x is representing what?
Hours.
All right, so x is the hours that we work or that Cole works, and the money earned would be f of x. Everybody agree?
Yes.
All right. What if, and Cole gave us a nice easy example by giving us 10, what if we wanted to say Cole wants to save up for a prom bid that's like, what are they, $200?
So I'm saving up for the France trip.
Let's use that. So, okay, so Cole is saving up for a trip to France, which costs about how much?
$4,200.
That's crazy. That's a lot of hours.
4,000 what?
$200.
All right. So Cole wants to save for France. That's $4,200. So how would we go about writing an equation that will give us the number of hours that Cole has to work to earn that $4,200? So in other words, the input now is going to be the money that Cole earns or wants to earn, and the output is going to be how many hours he needs to work to get it. Alexis, go ahead. looking for a function. So what do I have to do? If I enter some amount of money, like 4,200, what do I have to do to that to get the number of hours that Cole has to work to go to France? Divided by 10. So in other words, F inverse of X, in this case, is going to be, take the input value, which in this case is not hours worked, but it's money that we want to earn, and divide it by 10. Do you understand that?
Yes.
All right, so if we enter $4,200 and divide by 10, how many hours does Cole have to work? 420 hours to go to France. All right? All right, so notice, please, that multiplying by 10 is the inverse operation of dividing by 10, right? Inverse operations, inverse functions, very closely related. All right, so let's talk about the function f of x equaling 3x. Can I have everyone's attention, please? I sure hope you're taking some good notes. Okay, if the domain for this function is 1, 2, and 3, what would the range of this function be? Michael M. All right, so the range would be 3, 6, and 9. All right, because if we plug in 1, we get 3, plug in 2, we get 6, and so on. So what is the inverse operation of multiplying by 3? What would be the inverse of f of x equaling 3x? Brian? All right, so we could say the inverse operation is dividing by 3. So we could even write the inverse function as x divided by 3. So in this case, f of x and g of x are inverses of each other. And we could interchange the coordinates to get points on this inverse function. So we had on the original ordered pairs 1, 3, 2, 6, and 3, 9. What would be the corresponding ordered pairs on the inverse function? What ordered pairs would be on the inverse? Emily C. We want to interchange the coordinates to get ordered pairs on the inverse. So instead of 1, 3, if I plug in 3, I'm going to get 1 and so on. So what are the ordered pairs? We're looking for ordered pairs. 3, comma, 1. We're just switching the x's and the y's. 6, 2, and 9, 3. Everybody agree? All right. So inverse functions, all the coordinates will be switched from the one function to the other.
But the domain is a range of the same.
And the domain and the range will be switched also. So here's our inverse function. F inverse of x equals x over 3. Note that the domain of f is the range of f inverse and vice versa. All right. By the way, we use this symbol f with the little -1. Have you seen this prior to today? Okay, so let's talk about this for a minute. This is a notational thing. This means the inverse of function f. Okay? And we would read it f inverse. All right? So we're talking about the inverse of function f.
Wait, I have a question.
Yes.
The domain of the inverse of x, 3x, would be, the domains would be 3, 6, and 9.
Yeah, so let's go back up. Where's my, okay, so right here, for our inverse function, the domain is going to be, what did you say, Cole? 3, 6, 9.
That's,
And what about the range? 1, 2, 3. So notice the domain of the original domain of the original became the range of the inverse, right? And the range of the original became the domain of the inverse. Everybody with me? Okay? All right. And so a function and its inverse undo each other. All right, so if you multiply by 3 and then you take that new number and you divide by 3, won't you get back to your original number?
Yeah.
If you add 5 to a number and then you subtract 5 from that number, won't you get back to your original number?
Sure thing.
So inverses undo each other. All right. So that means if we take the composite f of f inverse of x, what should we get?
0.
F,
X.
I hear 0, f, x, 7. Block 7, this is not a proud moment for me in block 4 right now.
Well, it's my league card.
All right, so if we use f of x as 3x, and f inverse of x was x over 3. And we're going to do f of f inverse of x. That means we want f of what? X over 3, which means we're going to go to the f function. We're going to take out the x, and we're going to replace it with x over 3. So I'm going to get 3 times x over 3, and I'm going to get what?
X. So is that in all cases?
That's what I said.
Oh. F negative 1, 0x.
We read it f inverse, yes. So Cole got that important summary. I hope that the rest of you did, but some of you were talking. Some of you are still talking. So f of f inverse of x is always going to be x, and f inverse of f of x is always going to be x, because they always undo each other. So we could do the same thing with f inverse of f of x. In this case, we'd be taking f inverse of f of x was equal to 3x. So if we want f inverse of 3x, we're going to plug 3x in right here, and we would get 3x over 3, which is
X.
yes. So what did we learn? We learned that f of f inverse of x is equal to f inverse of f of x, and they're both equal to x. All right.
So we see it's X.
So
Yeah. Yeah.
So here's our formal definition for inverse functions. If f and g are two functions, so that we can take the composite f of g and g of f, and we get x both times, then f and g are inverse functions. All right? So if f and g are two functions, so that when we take the composite f of g of x and the other way, g of f of x, and we get x both times as our answer, then f and g are inverse functions. Everybody okay with that?
Yeah.
All right, and this is what I wrote on the other page. The g function, though, is denoted by f inverse, all right? And I wrote this on the other page. F of f inverse of x equals f inverse of f of x, which equals x. Note, f with a little negative 1 and x means the inverse of f. It does not mean the reciprocal of f. All right, it's just a notational device as opposed to, when we have something like, x to the, let me use a fraction instead. If we have something like 2/3 raised to the negative 1, isn't that the same as 1 over 2/3?
Yeah.
Yes?
Yes.
But that's not the case with functions. F inverse of x is not equal to 1 over the original function. Does that make sense?
Yes.
All right?
just begun, God 7.
All right, so,
How do you fix it?
we'll talk about that. Okay, can I have the talking stop, please? In this example, which of these functions is the inverse of f of x equaling 7x plus 4? Is it g of x, which is x minus 7 over 4, or is it h of x, which is x minus 4 over 7? I don't want you to answer right now. I want you to think about it, and I would actually like you to put pencil to paper and use what we just talked about. How do you find out whether two functions are inverses of each other? What do you do to determine whether two functions are inverses? Plug them into each other, take the composite, and what are you looking for? You're looking to see if you get x. Would you do that now, please? So you are going to find f of g of x, see what that works out to be. If it turns out to be x, great, then better try g of f of x. But if it doesn't turn out to be x, then abandon that and try f of h of x and see if that works. All right, do you have an answer? Which one works? H of x is the inverse? So f of h of x, I'm sorry. That's not what I wanted to do. F of h of x is going to be f of x minus 4 over 7, which is going to be, I got to plug that in right here. So I want 7 times x minus 4 over 7 plus 4. Does that look right?
No, it's the other way around. It works.
I got the same with John.
Yeah, it works.
All right, well, hang on a second. We all have to agree that this is correct. If I'm doing f of h of x, isn't that f of x minus 4 over 7?
It does work though.
Hang on, you're not understanding me. We need to show that f of h of x is equal to x, and we need to show that h of f of x is equal to x. But if you are writing down f of h of x, but ending up with all the work for h of f of x, then I'm going to take off points. You with me?
Wow. Wait, but why can't we?
So you need to show this, what I have so far. Are we agreeing that this is the work for f of h of x?
Yeah.
Okay, then what you're going to show me, I do not want to see this. Don't show me this.
I can do that.
No good. I will take off points because you need to show me step by step what is happening here.
Okay. I'm about to draw that.
So instead of slash, 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 what would we be taking out first? The 7s or the 4s? All right, so we're going to divide out the 7s, and then you're going to rewrite for me x minus 4 plus 4. Now you can show me that the 4s subtract off, and we're left with x. Are we okay with this? F of g?
No, why can't you show f of x?
You can do them in whatever order you want, but don't write down f first, then h, then x like this, and then show all the work for h of f of x.
Well, we did it. I
Alright,
did
so
it. I did
let's
it.
keep going because we have to show that it works the other way also. We need h of f of x, which is going to be h of, what was f of x? 7x plus 4. Now we got to plug in 7x plus 4 into the h function right here. So we're going to write 7x plus 4 minus 4 over 7. Does that look right?
Yeah.
All right, so now, instead of me slash, 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 what are we doing first?
Subtract off the 4s.
Subtract off the 4s first. So the 4s subtract off, and then I write down to show my math teacher that I am doing exactly what I'm supposed to be doing. I got 7x over 7 now. I divide out my 7s, and I'm left with x. Everybody see what work you need to show to prove that two functions are inverses?
Yes.
Okay? Chad.
Real quick, is there a reason why we can't do the crossing off? Like, see how you have like like at the top with the red? You said you'll list once and you'll just cross everything off. Is there a reason why?
Because you're not showing me in which order. I don't know, maybe you thought you could, up here, maybe you thought you could subtract off the 4s first, but you cannot subtract off the 4s before you divide out the 7s. Does that make sense?
Well, if we get the same, if we get the right answer though, it's an assume that we did it right, because if we didn't get it right, we get it.
I've learned long ago never to assume anything when it comes to my students and their understanding of math. All right, I leave nothing to my imagination.
He's just
All right.
saying that because he slashed the guy off.
You know, that's exactly why I say.
You didn't have this work right there.
Okay,
I
so,
did it right now.
all right, let's take a look at this example.
Thank you, Chad.
On this example, I'm asking you to graph f of x, which is x squared plus 1, and I'm telling you that the inverse is f inverse of x equaling square root of x minus 1. All right? So let's forget about that for a minute. Let's just graph f of x equaling x squared plus 1. You know from all your hard work with transformations that this is going to be a parabola, and is it shifted, stretched, or reflected? Shifted. Which direction? Up 1 unit. So our function is going to look like this. All right. Okay.
I had sugar.
Stop. All right, so if we graph this function, and we only graph it though for x greater than or equal to 0, that means we really are going to erase this part and we only want this part. Everybody agree?
Yes.
Okay, and so what we were told is the inverse is square root of x minus 1. So if that's our inverse, f inverse of x, square root of x minus 1. Do you all have a picture in your head of the parent function, square root of x?
Yeah.
Draw it in the air for me. Okay, and what about shifting, stretching, reflecting? Shifting to the right 1. So instead of it being like this, 0, 0, 1, 1, 4, 2, 9, 3, right, like this, it's shifted over 1 unit to the right, so it's going to look like this. Agreed? All right, this little guy is supposed to move over here. All right, like this?
Yeah.
Okay, so what do you notice about these two functions and their graph in their relationship to each other?
I feel like this is just kind of
Kind of the same.
They're reflected.
They are reflected. They're reflected over what, though?
Y equals X.
Thank you, John. They're reflected over the line y equals x, which is this line right here. Do you see that these are mirror images of each other over that line?
Yes.
Okay. Now, question for you. If we had kept the whole function here, instead of just taking for x greater than or equal to 0, would look something like this. If we were to reflect that function, what would we have over here? Wouldn't we have a full parabola over here?
Yes.
Just a half a Well, that's fine, but what's the problem with that? Is this going to be a function?
No.
Why not? Doesn't pass the vertical line test, right? So I wonder if there's some way that we could test a function to see whether its inverse will also be a function.
We're gonna learn right now.
A horizontal line test.
No.
So
No
if,
way.
if we test this, So here was our original function before we did this limiting of the domain. If we tried a horizontal line test here, and we said, uh-oh, a horizontal line goes through that function's graph in more than one point, which means once we graph the reflection over the line y equals x, it's going to be this full graph here, which is going to fail a vertical line test. You with me? That means we cannot find the inverse of this whole function here. Right? This whole function does not have an inverse. But we can find the inverse of the function if we limit the domain, as was suggested in this problem, if we have a just x greater than or equal to 0. So now, if I erase this part of the graph, now will it pass a horizontal line test?
Yes.
Yes, which means that its inverse will be a function.
Good afternoon, Francis. We prepared this
Early.
It's so early.
All right. The substitute will have some more assignments for you.